Our singular approach of building a language, frameworks, tools, and services that all work together truly comes to life when we introduce a new platform. The use of shared foundations help make the platform seem familiar, while ensuring its individual strengths shine. Vision OS takes advantage of the investments we've been making in our platforms for many years and showcases the benefits of this approach. Here's Mike to tell you all about it.
The launch of Apple Vision Pro marks the beginning of a journey together in spatial computing. You can now push beyond what you previously understood to be possible and reimagine what it means to be connected, productive, and entertained. Vision Pro has many groundbreaking technologies. Your apps will make use of new elements to interact with the user's space and blend seamlessly with their room. This is all possible using powerful technologies you already know: SwiftUI, RealityKit, and ARKit, now extended for Vision OS. With this solid foundation and an updated set of developer tools, you're going to feel right at home creating an entirely new universe of apps for Apple Vision Pro. Today, we're going to cover everything you need to get started with Vision OS, from the fundamental building blocks to critical frameworks, tools, and technologies. You'll learn about the activities and programs we are launching to support you as you bring your apps to life on Vision Pro. Apps that take advantage of the infinite canvas of Vision Pro, or that turn a room into an immersive media environment. So let's roll our sleeves up. Vision Pro allows you to rethink what is possible for your app experience. Regardless of the kind of app you're building, you need to understand how it will exist in 3D in your user space. This will inform the decisions you make as a developer. That understanding will help you take advantage of the capabilities of Vision Pro, bringing focus and immersion to your apps in ways that, until now, were just not possible. By default, apps launch into the shared space. The shared space is where apps exist side by side, much like multiple apps on a Mac desktop. The user has full agency to reposition apps wherever they would like. Let's talk about the elements you can use inside a space, starting with the familiar window. On Vision OS, your app can open one or more windows, which are SwiftUI scenes and behave just as you would expect, as planes in space. They can contain traditional views and controls, and they even support 3D objects and reality views, allowing 3D content to sit alongside 2D content. Additionally, your app can create three-dimensional volumes, which are also SwiftUI scenes, and showcase 3D objects like a game board or a globe. Volumes can be moved around the space and viewed from all angles. In some cases, you may want more control over the level of immersion in your app, maybe for the user to watch a video, play a game, or rehearse a presentation. You can do this by opening a dedicated full space, in which your app's windows, volumes, and 3D objects appear across the user's view. So those are the foundational elements of spatial computing: windows, volumes, and spaces. They give you a flexible toolset to build apps that can span the continuum of immersion. Now, to tell you more about how to get started building apps, here's Jeff.
Vision Pro supports several different kinds of apps. Existing iPad and iPhone apps are supported each as a single, scalable 2D window with their original look and feel. But that's only the beginning of what's possible. At its core, Vision OS is similar to iPadOS and iOS, and includes many of the same foundational frameworks. You use SwiftUI and UIKit to build your user interface, RealityKit to present 3D content, animations, and visual effects, and ARKit to understand the space around the user. These are all part of the Vision OS SDK. So what does it take to bring your app to Vision Pro? First, in Xcode, add the Vision OS destination to your project. Now, when you rebuild, your app automatically gets some really cool improvements. Materials with the Vision OS look and feel. Fully resizable windows with spacing tuned for eyes and hands input. And access to highlighting adjustments for your custom controls. Then, you can add Vision OS specific code to expand your app into a collection of windows, volumes, or spaces. From here, you can begin to take advantage of the extended capabilities of SwiftUI, RealityKit, and ARKit. Here's Enrique to tell you how.
On visionOS, many of our frameworks have been extended to support spatial experiences. With SwiftUI, you can now add depth or add a 3D object inside a window. On iOS and macOS, a Z-stack is typically used for layering views. visionOS goes further, and you can separate them with depth. This gives your two-dimensional apps a three-dimensional feel. You can add subtle changes in depth to your UI elements by using the new Z offset view modifier. A higher offset value presents the view in front of views with lower values. And you can use this to show emphasis or to indicate a change in modality, for example, when showing details for a selection. And with additional view modifiers, you can have more control over width, height, and depth. On Vision Pro, even gestures are aware of the additional space. We are all used to dragging objects around the screen. Now people will be able to move or rotate objects anywhere in their physical space. You can also create a volume with SwiftUI. It can exist alongside your app windows, and when running in the shared space, sits side by side with other apps. And SwiftUI windows and volumes can also be inside a full space, where you can place 3D objects and SwiftUI elements anywhere in the user's room. Not only can SwiftUI quickly and easily bring your apps onto visionOS, it can also render fully immersive experiences. And SwiftUI now renders through RealityKit, so you can easily mix SwiftUI and RealityKit APIs. You can utilize UI enhancements like ornaments, materials, and hover effects. Ornaments allow you to affix UI components to the edges of your windows and volumes. They're great for things like toolbars and menus. Hover effects highlight UI elements in response to where a user looks. While system controls automatically get these effects, you have options to decide whether your custom control shows a highlight or a glow. And materials adapt to the world around your user. Dynamic blurs and vibrancy make your app readable no matter the conditions. Just like on our other platforms, we recommend you use SwiftUI to build your visionOS apps. Your existing apps built with UIKit can also be recompiled for visionOS and will get access to ornaments, hover effects, materials, and the native look and feel. SwiftUI is just one of the frameworks you'll use to build spatial experiences on visionOS. Edwin will walk you through a few more that will help you on your journey.
When you're ready to extend your apps with full scenes of dynamic 3D models, animations, and visual effects, you'll want to use RealityKit, Apple's 3D rendering engine built from the ground up for rendering spatial experiences. We introduced RealityKit and SwiftUI together in 2019 as independent frameworks. On Apple Vision Pro, they are deeply integrated so you can build sharp, responsive, and volumetric interfaces. 3D content can bind to SwiftUI views and states, seamlessly coupling 2D and 3D visual elements together. RealityKit automatically adjusts the physical lighting conditions and grounds the experience in reality by casting shadows on floors and tables. This makes your app look like it belongs in the room. RealityKit also has significant new capabilities, including the ability to create portals into 3D scenes, like the dinosaur we saw in the Keynote, to render incredibly sharp text so you can read comfortably, and a customizable material system to create stunning visual effects. Additionally, rendering is even more efficient on Apple Vision Pro by using a technique called dynamic foveation. RealityKit leverages eye tracking to selectively render regions the user is focusing on at very high fidelity, reducing the rendering cost of content in the periphery and enabling your apps to maximize the processing power of the device. RealityKit renders your 3D models with stunning photorealistic results by allowing you to specify its physical properties, such as how reflective or metallic it is. By default, RealityKit renders virtual content so its lighting is connected to the lighting conditions of the physical room. If you want to customize or even extend the realism based on your creative intent, you can provide an image-based lighting asset, or IBL, to individualize the look. For authoring your materials, RealityKit has adopted Material X, an open standard for specifying surface and geometry shaders used by leading film, visual effects, entertainment, and gaming companies. The broad support for Material X across a variety of industry-leading creation tools makes it much easier to write shaders. Material X lets you design and rapidly iterate on the look of individual materials by allowing you to define its shading properties. There are repositories of materials you can choose from and helpful tools like Houdini and Maya that can be used to author your own custom shaders. RealityKit provides a new Swift UI view called Reality View. Reality View can be used within windows, volumes, and spaces, letting you place 3D content anywhere you want within the scenes that you control. It also supports attachments, which allow you to embed 2D Swift UI views with your 3D content. Alongside Swift UI and RealityKit, a third powerful framework enables you to take full advantage of the user's surroundings, ARKit. ARKit understands the space around the user, allowing app content to interact with the room, whether it's a ball bouncing off the floor or water splashing on the wall. ARKit hosts the real-time algorithms on Vision OS that power a host of core system capabilities. These algorithms are always running, which means your apps automatically benefit from ARKit in the shared space, no matter how they're built. Persistence and world mapping are handled by the system. Segmentation, matting, and environment lighting are automatically applied to the entire space. And with the user's permission, ARKit features can be made directly available to your full space apps. Inside a full space, your apps can interact realistically with the room by leveraging ARKit's plane estimation, scene reconstruction, image anchoring, and world tracking, which uses the same anchor concepts as ARKit on iOS. This makes migrating your existing ARKit app to Vision OS easy. And on Vision OS, you now also get access to skeletal hand tracking. You can use hand tracking to create custom gestures for your app experience, or even augment the user's hands with digital information. ARKit provides positioning and orientation of joints in the same skeletal model introduced on iOS. With the integrated approach across Swift UI, RealityKit, and ARKit, you can leverage the learning and investment you've already put into Apple platforms over the years. And that includes efforts you have put into making your apps accessible. This is especially meaningful because spatial computing opens up great new opportunities for accessibility. On Apple Vision Pro, users with physical and motor disabilities can interact with their device entirely with their eyes, or their voice, or a combination of both. Users can also select with their index finger, their wrist, or their head as an alternative pointer for navigating Vision Pro. You'll make your apps accessible on Vision OS with the same techniques you use for years on our other platforms. Accessibility Inspector analyzes and reports accessibility issues in your Vision OS apps and gives you suggestions on how to make them more accessible. And with the accessibility support built into our frameworks, it's easy to bring your Vision OS apps and experiences to users with disabilities. For example, you can help VoiceOver describe objects in your apps to users who are blind or have low vision by adding labels and descriptions that convey information, like an object's physical appearance. You can also incorporate user preferences to make your apps more accessible by design, such as dynamic type for larger text sizes, reduced transparency for better legibility, and alternatives to headlock content. By making use of these familiar APIs and tools, your apps will play a huge role in making spatial computing accessible to users around the world. So that's an introduction to the powerful frameworks you can use to build amazing Vision OS apps. Now here's Tessa to talk about all the tools available to you.
As you start building apps for Vision Pro, you'll recognize more than just the frameworks. Our developer tools have also been updated to support Vision OS. Just like for all our other platforms, Xcode is at the center of your development experience for Vision Pro. You can add a Vision OS destination to your existing projects, or you can build an entirely new app dedicated to the unique capabilities of this platform. The first step in building your app is getting the look right across both 2D and 3D content. Xcode Previews lets you rapidly iterate on appearance without leaving the editor. When it's time to start testing your entire app, you can move to the simulator, which provides a powerful environment to run and debug your app. You can move and look around the scene using a keyboard, trackpad, or a compatible game controller. And you can interact with your app by simulating the system gestures. The simulator also provides 3 different simulated scenes with day and nighttime lighting conditions to help you visualize your app. When it comes to developing with your Vision Pro, you'll be building and running your app on the device to make sure it's working. I'm super excited to share this additional feature that will change the way you work. Mac Virtual Display lets you bring a high-fidelity 4K virtual monitor of your Mac right into your Vision Pro just by looking at it. You can use the full capabilities of your Mac from within your device, and that includes Xcode. This is an incredible end-to-end development experience, coding, testing, and debugging your app on your Vision Pro the entire time, without any interruptions or loss of context. Sometimes you need to dig into the details of how your app's content relates to the real world. When your app interacts with the user's room, it can present unique challenges, such as 3D content visually clipping through walls. Xcode features practical debug visualizations to help you explore collisions, occlusions, and scene understanding as it relates to your 3D content. These visualizations work both in the simulator and on Vision Pro. As you evolve your Vision OS apps, they will become more spatial, breaking outside the boundaries of flat windows and bringing 3D experiences to users unlike ever before. Doing this right requires a new visual tool. That's why we made Reality Composer Pro. Reality Composer Pro is an application that lets you preview and prepare 3D content for your Vision OS apps. You can import and organize assets such as 3D models, animations, images, and sounds. It integrates tightly with the Xcode build process to optimize your assets for use on Vision Pro. You can easily send your content to Vision Pro to preview, size, and rotate it. Push new changes at any time, and see how your content looks before ever typing a line of code. Here's Jason to give you a tour.
I've been working on one of our sample projects that takes you through the solar system. I want to make sure my 3D content looks great on Vision Pro. And I'm going to use Reality Composer Pro to update it now. I'll start by importing the satellite model and images that I made in my 3D modeling application. This model has a lot of details, but presently no materials. I'll create a custom material in Reality Composer Pro, and then I'll jump to the shader graph where we can customize it. It's easy and fun to add some simple images and function nodes to change the look of an object, all without needing to get into code. You can try things and see the results instantly, and you'll never get compiler errors from having to hand type shaders. I'll repeat this for the other nodes too. At any time, I can preview my work right on my Vision Pro. I can scale it, move it, or rotate it, and make sure it looks and feels how I want. I like these changes. And then jump back into Xcode, where my changes have been reflected in my project and are ready for use in Xcode previews or the simulator. Just like that, ready for me to load in code and use in my app. With Reality Composer Pro, your Vision OS development process has a powerful new tool that works side by side with Xcode, making previewing and preparing 3D content as easy as building and running your code.
When you're ready to beta test your app, TestFlight will be available to use on Vision Pro from the start. Submit new builds to TestFlight just as you would expect, through App Store Connect, Xcode, or Xcode Cloud. And testers can install them and provide valuable feedback right from the native TestFlight app. They can also access beta builds of your compatible iPad and iPhone apps on Vision Pro. With this family of development tools and services, from Xcode to TestFlight, and now Reality Composer Pro, you'll be well on your way to making amazing apps for Vision Pro. And now back to Mike.
Many of you have invested years building 3D apps and games with Unity. To make it easy to bring your apps to Vision Pro, Apple and Unity have been deeply collaborating to layer Unity's real-time engine on top of RealityKit and enable their development tools to target visionOS. This means that Unity-created apps can coexist with other visionOS apps in the shared space and take full advantage of the unique benefits of Apple Vision Pro. To tell you more, I'd like to introduce Ralph from Unity.
Thank you, Mike. It's been truly exciting to collaborate with Apple on our deep integration for visionOS. Now you can use Unity's robust and familiar authoring tools to create new visionOS games and apps. And you can bring your existing Unity-created projects to Vision Pro to reimagine your experiences for this new platform. Your apps get access to all the benefits of visionOS, such as high-resolution pass-through and dynamic foveated rendering, in addition to familiar Unity features like AR Foundation. And with this deep integration between Unity and visionOS, your apps can even appear alongside other apps in the shared space. By combining Unity's authoring and simulation capabilities with RealityKit's managed app rendering, content created with Unity looks and feels at home on visionOS. With Unity, you'll be able to get started quickly with our community, our tutorials, and templates. We believe that Apple Vision Pro has launched a new frontier of spatial computing, and we're really excited to see the brand new apps and games that you will create.
Thank you so much, Ralph. It's been amazing working with you. There are a few more fundamental features of visionOS that you should know when you're planning your next steps. Here's Jeff to give you all the details.
The frameworks you use to create apps for Vision Pro were designed with two goals in mind: to enable you to leverage the platform's powerful hardware and software with minimal effort, and to preserve user privacy. You can see these principles at work throughout the system, from the way apps blend in with their surroundings, to the natural user interactions, to the new possibilities for collaboration. visionOS builds a 3D model of the user's surroundings to enable realistic lighting and shadows. As a result, apps can naturally blend in with the world around them without needing access to camera data. visionOS uses this same 3D model to enable the next generation of spatial audio for your apps. In the real world, sound reverberates through and around a space, bouncing off walls and furniture before arriving at a person's ears. Your app's virtual sound should behave the same way. This requires a sophisticated understanding of the user's surroundings. The Phase spatial audio engine in visionOS fuses acoustic sensing with 3D scene understanding to create a detailed model of the sonic characteristics of the space. As sound sources and the user move around the environment, Phase updates its audio ray-traced simulation in real time. This model combines with Apple's personalized spatial audio technology to tailor the experience to each individual and their surroundings automatically. All of this incredible complexity is managed for you, and you don't need access to any details of the user's physical space. Using RealityKit, you simply decide where you want sounds to come from, and visionOS naturally mixes them into the real world. Just like the algorithms that power realistic lighting and audio in your apps, user input on visionOS works automatically and is private by design. Hover effects render automatically for any UI elements built using SwiftUI or RealityKit. If a user looks at a button, it highlights before they tap on it. And just like a click of a mouse or a tap on an iPhone, your app is notified of a selection when a user taps their fingers. The user gets the visual feedback they need, and you receive the interactions you expect without needing to know where the user looks before they tap. Sharing and collaboration are a central part of the Vision Pro experience. Just like on macOS, Vision Pro users can share any app window with others on a FaceTime call. And with SharePlay, next generation's shared experiences become possible. When your app adopts SharePlay with the Group Activities API, the sharing control over each window adds an option that launches your app for everyone on the call. This allows them to participate in a truly shared experience, together in real time. You decide how your app can be used collaboratively, just as you have for SharePlay on our other platforms. A Vision Pro user on a FaceTime call appears to other participants as a persona, a natural representation created with advanced machine learning techniques that dynamically matches their facial and hand movements. Personas appear to other Vision Pro users with three-dimensional volume and depth. But we want to take FaceTime to the next level on Vision Pro and empower users anywhere to interact like they are actually in a room together. This experience is still in its early form, and we're excited to share it with you here for the first time. Spatial personas allow Vision Pro users to break out of the familiar FaceTime tile and feel more present, like they are gathered in the same physical space. Vision OS ensures that users and apps have a shared and consistent spatial context. Your apps can take advantage of this new context with SharePlay. Now, beyond just synchronizing changes in your app between users, you can respond to a user's physical actions, so that standing together at a freeform board or moving pieces in a tabletop game feels natural. We want your apps to be a part of this incredible new experience, and your feedback will be important as it continues to develop. That's why we're making a developer preview of spatial personas available to you later this year. These are just a few more examples of the rich, extensive technologies you can take advantage of on Vision OS. Now, here's Linda to talk about where you'll go from here.
Now that you've been introduced to Apple Vision Pro and Vision OS, what's next? Your development journey starts today. We encourage you to dive in and learn as much as you can as you begin designing, developing, and testing for Vision Pro. The Vision OS SDK, along with an updated Xcode and simulator, and Reality Composer Pro, will be available later this month, so you can start working on your ideas. You'll also have access to extensive technical documentation, new design kits and tools, and an updated human interface guidelines for Vision OS. In addition to the Vision Pro simulator, we also have options for you to see how your app works on Vision Pro. This summer, we're launching the Apple Vision Pro Developer Labs, where you can test your app on Vision Pro hardware. You'll have hands-on support and an ability to preview your experience before Vision Pro is released to customers. These labs will be located in several locations around the world, including our Developer Center here in Cupertino. And no matter where you are, you'll be able to submit a request for us to evaluate your app's compatibility with Vision Pro. We'll install your app and share any issues we may find. To get further updates on these exciting opportunities, visit the developer website. And of course, Vision Pro will launch with a brand new app store, so people can discover and download the incredible apps you create. We invite you to share your ideas for this platform, and we'll continue to support you as you bring them to life. Now back to Darren.
What an exciting year. An incredible opportunity with Vision OS. So many thoughtful additions to each platform, like more places to surface your app with WidgetKit, an expansion of Continuity Camera, and a new design for watchOS. Plus major enhancements to Swift with macros and Swift data, and a big upgrade to Xcode previews. This year's developments across languages, frameworks, tools, and services represent our deep commitment to helping you create unique experiences for billions of devices across our platforms. These platforms span an increasingly diverse range of products with a level of consistency and integration that make a difference to you as a developer and to users. We successfully scratched the surface of what's new in our platforms. But to go further, we have 175 in-depth video sessions, 40 for Vision OS alone, along with over 200 labs staffed by Apple experts to answer your burning questions as you build great apps. There has never been a better time to be an Apple developer, and I have no doubt what you create will astound and delight your users. Have a fantastic WWDC.